Hello everyone. Today I will show you how to use binary logs for point-in-time recovery. Sometimes misoperation is unavoidable. Imagine that one day you deleted a table on an online MySQL server and a lot of data was inserted into the MySQL instance after the misoperation, and you only have this one online MySQL instance to use. How can you recover MySQL without losing any data? Now, let's see how to restore this MySQL instance using binary logs. First, we use MySQL dump to make the full backup of the test database. We use the single transaction and source data parameters in the backup SQL statement. For point-in-time recovery, when you need to restore an old backup and replay the changes that occurred since that backup, you can use these two parameters to get the binary log coordinates corresponding to the dump. Now, let's create some data for testing. We log in to the MySQL instance and go to the test database, create a table called test1 with a column called T1, and insert 3 values into the table, namely T11, T12, T13. At this time, we accidentally deleted the test1 table. Although we regret it, the test1 table is gone. But MySQL is not stopped, so some operations are still in progress. We create another table called test2 and insert 3 values into the test2 table. After inserting 3 values, the binlog has reached its maximum value. MySQL needs to create a new binlog file to continue recording database modifications, so we execute the SQL command, flush logs to simulate MySQL internal operations. After creating the new binlog file, we insert a value into the test2 table again. Now, let's take a look. The query table has 4 values. Now let's restore the test1 table. We need to set the variable SQL_log_bin to 0 to disable logging of any modifications. Then we restore the last full backup created before the point in time of interest, which is the last full backup before the drop operation. Find the exact binary log event position corresponding to the point in time that the database is to be restored. This full backup log event position is located on the file binlog.0000099, and the position value is 198. In order to help us find the binlog file that records the drop operation, I wrote a script to do this. Now we can know that the file binlog.0000099 records the drop operation. After we have the information of the binlog file name that records the drop operation, we can find the drop table test1 statement in the segment between positions 777 and 907 of the binary log from the output of MySQL binlog, which means that the statement occurs after log position 777, and the log after the drop table statement is at position 907. Apply the events from the binary log file to the server, starting from the log position you found in the previous step, which starts at 198 and ends at 777, and then we apply the binary log file events after position 907. In addition to the binlog file binlog.0000099, we also need to apply the binlog file binlog.0000100 to the MySQL instance, which records the operation of inserting the last value into the test2 table. Take a look at this GIF. It is easier for us to understand the recovery mechanism using binary logs. At binlog file position 198, we use the full backup to restore the MySQL instance. Then, we restore the binlog file binlog.0000099 from position 198 to position 777, not included, into the MySQL instance. In the third step, we restore the binlog file binlog.0000099 from the starting position 907 to the end position into the MySQL instance. Finally, we restore the complete content of the binlog file binlog.0000100 into the MySQL instance. Let's take a look at the recovery results. We can see that there are 2 recovery-related tables in the test database, test1 and test2. The test1 table was dropped before and is now recovered. No data is lost in these 2 tables. Thank you for watching. See you next time.